All right, guys, let's go ahead and continue with this review. Part 2, the number 19. For 4 cosine x sine y minus square root 6 equals 0. Obviously, find dy dx at the point pi over 6 pi over 4. All good, thank you. Okay. Let's go ahead and do a implicit derivative here. I am going to have to do a product rule. Notice the cosine has an x, the sine has a y. This is a little weird. Let's figure this out. Derivative of the first. Okay, derivative of cosine is negative sine times the second. Alright? And then I have the first times derivative of the second, and the derivative of sine y is cosine y dy dx. The derivative of a constant is 0 equals 0. Okay? Now I actually think what I want to do is I want to go ahead and plug in these numbers first before getting dy dx by itself. It's not like that different, but I want to show you guys how to do this, okay? Okay, look, this is x, this is y. So x is pi over 6 sine y. That's y is pi over 4. X is pi over 6. Y is pi over 4. Okay. The sine of pi over 6, again, if you guys remember your trig chart. Alright, so you would like make this real quick or whatever, and you'd be like, okay, the sine of pi over 6 is a half. Sine of pi over 6 is a half. Keep switching back and forth here. And then, if you want to go back and rewind and look at it, you can. The sine of pi over 4 was root 2 over 2. The cosine of pi over 6 was root 3 over 2, and the cosine of pi over 4 was root 2 over 2. Okay, so you can go back and look that up, but that all came from my chart, alright? Okay, so 2 and 4, those will cancel out, so that's cool. So that's negative root 2. 2 and 2 and 4 cancel out, so that's plus square root 6. Sorry, this one has a dy dx on it, equals 0. I'm going to add the square root 2 over. I'm going to add that to both sides. Square root 6 dy dx equals square root 2. When I add that over, dy dx is root 2 over root 6. I'm happy with that answer. You divide both by 2, and you could go square root of a third. You could go, the square root of 1 is 1 over square root of 3. Like, there's plenty of ways you can write it. Okay? Any of those would be perfectly fine. Alright? Alright, nice. Okay, guys, fun inverse questions. Now, we did this stuff today. I think you really got it in class. So let's see. You're going along. You get this. You get given the point 2, negative 1 is a point on the graph of f of x equals x3 plus x minus 11. Find f inverse prime negative 1. So every time you're doing these, we're going to follow the same process, okay? Okay, we start with that, and we say, okay, I'm going to do f inverse prime of negative 1 equals 1 over f prime of something. Then I say my whole goal right now is to find out what number goes right there. All right? Go off to the side, drop the primes, and that means that f inverse of negative 1 equals something, which means f of something plus negative 1. So that's not like magic point that goes back and forth. Okay? Now, if, let's pretend like it didn't give me that point, that'd be a little tricky. I'd have to set that equal to negative 1, and I'd have to solve it. Okay? I could do that with a calculator or otherwise, no. But the good news is it did give me that point, and it said that that is on f, the graph of f. So the point 2, negative 1 is on that, which means if f of 2 is negative 1, f of negative 1 is 2. So this is that like magic point I'm talking about. So that's negative 1, that's 2. So now to solve this problem, all I have to do is figure out what the heck is f prime of 2. And if I can figure that out, I got it, right? Well, I have f of x. I could get f prime of x by saying that's 3x squared plus 1. Therefore, f prime of 2 is 3 times 2 squared plus 1. 3 times 4 is 12, plus 1 is 13. So f prime of 2 is 13, but remember that means my answer is 1 over 13. Okay? So it's like the same process every single time with these inverse derivative things. Alright, let's look at 21. Another one. So g of x is e to the x plus 3x. Find g inverse prime of 1. Feels like they didn't give me enough information here, you guys. But let's check it out, see what we can do. Okay. So I'm going to start with what I want, which is g inverse prime of 1. And that's going to be 1 over g prime of something. And I don't know what that is. I go off on the side, and I go, okay, well, g inverse of 1 is blank, which means g of blank is 1. Okay? Now, this one didn't give me a point on the graph, so that means it's going to be a little bit trickier. But let me think about this for a second. I know g of is e to the x plus 3. So e to the x plus 3x equals 1. This is definitely going to have to be a calculator problem. I don't believe it said on here use a calculator. It's easy. It should have, because you cannot do this without a calculator, I don't believe. You know, we talked about in class, like, I can go through and try a few things. Oh, you know what? No, this is a calculator. We're good. I would say go through and try a few things. 0, 1, 2, none of them work. So, hold on, okay? If I plug in 0, I made this like classic mistake. E to the 0 is 1. 3 times 0 is 0. 1 plus 0 is 1. It actually works. Okay, it works when I plug in 1. So I told you if you're supposed to do it like that, like, I thought I had to go to a calculator. I just had to think about it a little harder. Okay, so if I plugged in 0, I got 1, which means g inverse of 1 is 0, which means that that's 0. Okay, and now all I need to do is figure out what g prime of 0 is, and I'm golden. First, let's find g prime of x. G prime is e to the x plus the derivative of 3x is 3. G prime of 0 is e to the 0 plus 3, which is 1 plus 3, which is 4. So this derivative is 1 over 4. Cool. Alright, not bad. Now, we're going to do a couple of related rates questions. Alright, a point moves along the curve, y equals square root x, so that the, okay, now let's read these words. Y coordinate is increasing at a rate of 4 centimeters per second. Whenever you said at a rate of or increasing or whatever, guess what that is, guys? That's dy dt. That's how much y is changing with respect to time. Okay? And then it says, find rate of change of the x coordinate. So it's basically telling me, okay, find dx dt. Find the rate of change of the x coordinate, find dx dt when y equals 2. Alright? When y equals 2. Okay, perfect. I'm going to take this and I'm going to take the derivative of it. Alright? With respect to time. Okay, with respect to time. Derivative of y is 1 dy dt. The derivative of the square root of x, remember this is x to the 1/2. It's 1/2 x to the negative 1/2 dx dt. Now you guys remember with related rates, you have to do a d whatever dt to everything. So x and y are both these different variables that we're taking with relation to time. Okay? So this says dy dt, which I know was 4. 1/2. This is x to the negative 1/2, which I actually don't know, and dx dt, which I'm looking for. So I'm missing too many things. How do I find x? Well, we kind of talked about this before, you guys. check this out. If y is 2, what would x be? Can you guys look and tell? I mean, if not, just go like this. If y is 2, what does x equal? Square both sides. X is 4. So that's cool. So I can put that in here. Okay? And let's just finish solving this. Now you guys, 4 to the negative 1/2, it's 1 over, and it's the square root of 4 on the bottom. Square root of 4 is 2, that's 1/4. So to solve for dx dt, if I divide both sides by 1/4, well, dividing by 1/4 is the same as multiplying by 4 over 1. So dx dt is 16. And y was increased rate of 4 centimeters per second, so this is also going to be centimeters per second. Okay, that's my related rate for number 22. Let's look at number 23. All right. Okay, a block of ice. Draw my block of ice here. Oh, let's go. Artist rendering, this is incredible. Alright, block of ice is exposed to heat in such a way that the block maintains a similar shape as it melts. It's initially 2 feet long, no, 2 feet wide, 2 feet high, 3 feet long, so 3, 2, 2. Whatever, however the picture has it, okay? The rate and change of the width of the ice. So this is, okay, so hold on. Length, width, height, okay? The length and change of the width, dw dt, right, is negative 1/3 feet per hour. Find the rate of change of the volume. So I'm looking for dv dt. Find the rate of change of the volume when the width is 1. Okay? Alright, you guys. The volume of this, let's think here. Length, width, height. Okay? I want to put those all in terms of W though, and since it's decreasing at the same like rate every time, I think I could put this all in terms of W. I don't like love this, but I think it makes sense. This one and this one would be decreasing the same because they're both 2 feet. They'll be together. So it's W, W, and L is, okay, well, I can do a quick proportion here. If L is 3, W is 2, and I could solve for L. L is going to be 3 over 2W. So, I just made this volume equation where volume is 3 over 2W cubed. Now I can derivative this. This one's a little tricky. Okay? dv dt equals 9 over 2W squared dw dt. Find the volume when W is 1 and dw dt is negative 1/3. So that's going to be negative, let's see here, can I do this? 3 goes into 9 3 times. Negative 3 over 2. Now, does that mean I have a negative volume? No, it means the volume is changing at a rate of negative 3 over 2, and let's see, this was feet, and per hour, since it's volume feet cubed per hour. Okay, negative 3 over 2 feet cubed per hour. Okay, now, looking at part B, so same like scenario here, this was part A. For part B, what's the amount of time it will take for the block of ice to completely melt? Well, I want volume to be 0. So let's see, how do we figure out if it's decreasing at a rate of time? Okay, let's think for a minute here. Well, we know that volume is 0 when the width is 0. Use W, not X. When W is 0. And I've got this formula here. I've got dv dt is 9 over 2 w squared dw dt. Actually, I'm sorry. I'm totally overthinking this. Okay. This is melting at a rate of -1 foot per hour. And right now, the width is 2 feet. So how long does it take 2 feet to decrease by a third? 1/3, 1/3, 1/3, and then 1/3, 1/3, 1/3. So that would take like a third of a foot per hour, so that would take 3 hours, and that would take 3 hours. So it would take a total of 6 hours. That's just like kind of thinking about it. I don't know. I don't love that question. Okay, and then let's go ahead and look at number 24. F inverse prime of 5 is what I'm looking for. And I know f of x is x3 minus 4x2 plus 3x minus 7. And it says on the interval 3 to infinity. Okay, why is it telling me that? Well, we'll see in just a minute. Alright, let's start over here. So f inverse prime, I'm looking for 1 over f prime of something. I have to find that point. Off on the side, I write f inverse of 5 equals blank, f of blank equals 5. So I need to know where this equals 5. I swear if it's not 1, I'm going to be really mad. Okay, it's not 0. 1, did it even tell me? No, that's lame. Oh, okay. On the interval 3 to 0 means it's not 0, 1, or 2. Maybe it's 3. I hope it's 3, for goodness sakes. 3 30 is 27 minus 36 plus 9 minus 7. So that's... No, it's not 3. Maybe it's 4. 4 is 64 minus 64. 3 times 4 is 12 minus 7, which is 5. That is so lame. That's the 0.45. I hated that. But if it's bigger than 3, I tried 3, I tried 4, and 4 worked, luckily. So they're not going to make you do something that you, like, can't do. You know what I mean? So here's my special point. 0.4 gives me 5, which means 0.5 gives me 4, which means I'm really just looking for f prime of 4, and I can solve this problem. Well, f prime is 3x squared, I'm getting this from here, minus 8x plus 3, and that goes away. F prime of 4 is 3 times 4 squared minus 8 times 4 plus 3. 16 times 3 is 48 minus 32 plus 3, which is 19. So this is going to be 1 over 19. Woo, that one was oozing. Okay? Oh, I have a few more questions. Oh, for goodness sakes, I thought I was done. That's alright. That is quite alright, guys. So we have... Oh, wait, oh, there's just a typo on this page, I think. Okay. So we have 25. Got a couple more we gotta do. Alright. E to the x squared minus 1, and it wants a second derivative. Well, guys, the first derivative is e to the x squared minus 1 times the derivative of x squared minus 1, which is 2x. Then guess what I have to do for my second derivative? A product rule, because the chain rule on the first one now gave me a product rule on the second. So it goes like this: derivative of the first, let's do the first, times the second, plus the first times derivative of the second, which is just 2. Okay, I'm not going to simplify that a lot of this. We're going to turn this into a guys. 4x squared, but I did the math. Again. Alright. I don't know why it has a, I don't know, my paper says something where it says like 27.15. But I think that's the next problem is number 27. I don't really know why that 15 is in there. Anyways, this is a quotient rule. I'm not going to simplify this, okay, guys? So, like, the derivative would go, derivative of the top. The derivative of the top is ln is 1 over x squared minus 1 times the derivative of x squared minus 1 for chain rule is 2x. Derivative top times bottom minus the top times derivative of the bottom all over the bottom squared. I would not simplify that. I'd leave that exactly like that. Okay? Alright, nice. And then there's y cubed minus x equals y ln x. This is an implicit question. Implicit. Y cubed is 3y squared dy dx. The derivative of x is just 1. And then I have to do a product rule here. Okay? The derivative of the first, the derivative of y is dy dx times the second. And then first derivative of the second. Now, I do need to get my dy dx's on the same side and everything else on the other side. So I think what I'm going to do, I'm going to go ahead and subtract this over. So it will say 3y squared dy dx minus ln x dy dx. Okay? And then I'm going to go ahead and add this over here. So that's going to say equals y over x plus 1. I will factor out a dy dx, and then I'll divide this whole thing over. Okay, so my final answer will be dy dx is y over x plus 1, and then 3y squared minus ln of x. Okay? Okay, 28. This gives me a bunch of information. F and G are inverses. Now, it says the graph G passes through the point negative 1, 2. And it says, oh, and the point 2, negative 1. Oh, weird. I'm going to write a statement real quick just from that. That means G of negative 1 is 2. And G of 2 is negative 1, which means that point is its own inverse. And then it tells me a couple other things. It tells me f prime of negative 1 is negative 2, and f prime of 2 is negative 1. Alright, let's not go crazy here. This is looking like it's already going to kill my brain. There's too much stuff, but I think I got this. Alright, G prime of negative 1 is 1 over f prime of something. You guys do it the exact same way every time. Do not try to do this in your head. It mess you up. So G of negative 1 equals blank. So F of blank equals negative 1. G of negative 1 is 2. That's what I'm going to use. So F of 2 is negative 1. So it's the point negative 1, 2. F prime of 2 is negative 1. So the answer is 1 over negative 1, which is negative 1. Now for part B. What is G prime of 2? Well, it's 1 over f prime of something. Got to figure out what that is. On the side, I write G of 2 is blank, so f of blank is 2. And I can use that point. So 2 is negative 1, so f of negative 1 is 2, so that's negative 1. F prime of negative 1 is negative 2. So this is no negative 2. Alright. Not too bad, not too bad. Alright, guys. Last little bit here. Okay. This is pretty cool actually. So assuming any C is like a constant. These are all techniques of how to do this, right? So I might talk about actual like questions here. But this is what's the derivative of a constant to a constant? This is what's the derivative of x to a constant? This is what's the derivative of a constant to an x, and then what's the derivative of a constant to a constant, or sorry, of a variable to a variable. Okay, constant to constant, variable to constant, constant to variable, variable to variable. Now, it's really hard just kind of looking at these. Let's think about this real quick. Let's say y was 2 to the third. What's the derivative of that? That's an example of a constant to a constant. What's the derivative of that? Well, 2 to the third is 8, and the derivative of 8 is 0. And that's going to be true for any time you have a constant to a constant. Well, the constant is 0. Okay? Okay, number 30. This is asking you about x to a constant. So x to the 10th, let's say, right? That's x to a constant. So how do we always do that? It was 10x to the 9th. Okay? So this derivative is, bring that down in front, cx to the c minus 1. That's the one I call the power rule, so we do with exponents, right? That's the power rule. Okay, now, this next one, y is, let's use a constant to the x, let's say 5 to the x. Okay, we learned that, right, guys? The derivative of a to the x is a to the x ln a. So the derivative of a constant to the x is 5 to the x ln 5. It's wanting you to see that these are different rules, right? If I have x to a number, whereas if I have a number to x, it's two different rules, okay? This one, we're not bringing it down and subtracting 1. It's a different rule. All right, this last one is really fun. You're not really going to probably see this on your test. Okay? And what we're going to do, you guys, is we can't really solve this the way that it is. We have to use something called logarithmic differentiation. Okay? Logarithmic differentiation says, I don't know how to take a variable to the power of a variable, but what I do know is if I take the ln of both sides, there's a property that says that I can bring that down in front. Okay? So I'm going to take the ln of y and the ln of x to the x, but I'm going to bring that down in front. So it just says x on x. That's the log property. Okay? Now I'm going to take the derivative of this, but I'm going to do it implicitly. Okay, the derivative of ln of y is 1 over y prime or dy dx. This is a product rule. Derivative of the first is 1 times the second, and then first times derivative of the second. So I have 1 over y dy dx, and I have this equals to ln of x, let's cross out, plus 1. Now that's cool, but I'm trying to solve for dy dx. I wanted to know what the derivative was, and I have like that little thing there. That's kind of annoying, right? So how do I get that out of there? Well, I divide by y, or I can multiply this y on the other side. You guys see that? So, dy dx is the ln of x plus 1 times y. And that's good enough there, but the thing that was, we kind of were like messing with this a little bit, because if you guys like, it just asked me for the derivative of x to the x, and everything was in terms of x, and now I have it in terms of x and y. So what could I possibly replace y with? Instead of writing times y, what does y equal? What can you guys see right there? Y equals x to the x. So my derivative is ln of x plus 1 x to the x. That one's pretty crazy. These three are just having you distinguish between your rules, but then that last one's a little bit. So, okay? I like it. Hopefully that made sense, and I'm going to get some more review questions that we can work on in class. All right, guys. Awesome. Dig in.